Write in the missing number. 1 plus 10 plus what equals 100? Well, 1 plus 10 is 11, and if we know our number bonds to 100, 11 plus 89 makes 100, so our missing number is 89. And we could work that out, because if we have a missing number addition, we can use subtraction to find our missing number. So because we know that 1 plus 10 is 11, we have 11 plus something equals 100, so we can work out the missing number by working out 100 minus 11, and that gives us 89 as our missing number. Put these temperatures in order, starting with the lowest. So we have 21 degrees, minus 13, minus 24, 0, and 35. Now we know that a negative number will always be lower than a positive number. So our lowest temperature is minus 24, then minus 13. Minus 24 is lower than minus 13, because if we were to imagine a number line, from 0 we would go back 13 to get to minus 13, but we would have to go back 24, so go back by more to get to minus 24. Then we have 0, 21 degrees, and then our largest or highest temperature is 35 degrees. These are some prices in a fish and chip shop. Alfie buys 1 fish, a large bag of chips, and a pickled onion. How much does he pay? Well, first let's find out how much 1 fish costs. That's £2.30. But he also buys a large bag of chips, and we want to know how much he pays altogether, so we need to add. A large bag of chips costs 90p, and I'm writing 90 pence like that because it makes it easier to add. £2.30 plus 90 pence is £3.20, because 23 plus 9 is 32. So we can work this out mentally without needing to use column addition. He also buys a pickled onion, so we need to add another 28p. So we have £3.20, and if we add another 28 pence, that gives us £3.48. So Alfie pays £3.48. Now Megan buys a sausage and a bread roll. Chen buys a small bag of chips and a curry sauce. How much more does Megan pay than Chen? So to answer this question, we need to work out how much Megan pays, then work out how much Chen pays, and then find the difference. So remember, we find the difference by subtracting. First, Megan buys a sausage, so that's £1.80, and a bread roll, so that's 30 pence. So altogether, she spends £2.10. Now Chen buys a small bag of chips, so that's 60 pence, and a curry sauce, so that's 40 pence. 60 pence plus 40 pence makes 100 pence, so £1. So how much more does Megan pay than Chen? Well, if we find the difference and work out £2.10 minus £1, we get £1.10 as our answer. Here is a doubling sequence. Write the 3 missing numbers. So first we have something times 2 is 38. So what we really have here is a missing number multiplication. And when we have a missing number multiplication, we can divide to find our missing number. So we can work out 38 divided by 2. That gives us 19. Now we need 38 times 2, so that's 76. Then if we multiply 76 by 2, we'll get 152. And then for our last box, we need 152 times 2. So that gives us 304. Here are 2 shapes on a square grid. For each shape, write how many right angles it has. So a right angle is like the corner of a piece of paper. So if we had the corner of a piece of paper, which corners would match up? Well, we could line up a piece of paper with this corner here and with this corner here. But we couldn't line up the edge of a piece of paper with this corner because this corner is larger. So that means for this shape, we have two right angles. And for this shape here, we could line up the corner of a piece of paper here, but we could also do the same here, here, and here. So for this shape, all of our corners are right angles, and all of our sides are the same length. So though it's tilted, this shape here is actually a square. So we have four right angles in this shape. And the way we show right angles is usually to draw a little square in the corner that's a right angle. Amy went on a cycling holiday. This chart shows how far she cycled each day. How much further did Amy cycle on Friday than on Wednesday? So if we find the bar for Friday, we can see that she cycled 16 miles on Friday, and then on Wednesday she cycled between 10 and 12, so that's 11 miles. Now we need to know how much further, so we need to find the difference, and we do that using subtraction. So we can work out 16 minus 11 to work out that she cycled 5 miles further on Friday than on Wednesday, because 16 is 5 more than 11. Now, how far did Amy cycle altogether on the 3 days she cycled the most? So she cycled the most on Friday, on Tuesday, and on Monday. On Friday, she cycled 16 miles. On Tuesday, she cycled between 14 and 16, so that's 15. And on Monday, she cycled 14. So we need to know how far she cycled altogether on these 3 days, because these are the 3 days when she cycled the most. So we can work out 16 plus 15 plus 14, and that will give us a total of 45 miles. Megan has a rectangular tile with this design on it. Here are 5 more rectangular tiles. Tick all the tiles that have the same design as Megan's tile. So if we rotate Megan's tile like this, we can see that it now looks the same as shape A. And if we rotate it a bit further, then it's easy to see that she has the same design as this design here. So the shapes that we need to tick are A and E. Here is part of a centimetre scale with 2 points marked. What is the distance between point A and point B? Well, we can see that point A is at 8 centimetres and point B is right in the middle of 12 centimetres and 13 centimetres, so that's 12.5 centimetres. So to find the distance between A and B, we can find the difference between 12.5 and 8. One way to do that is just to count on from 8. So we can count on 1, 2, 3, 4, and then another half a centimetre. So our answer is 4.5 centimetres. We can write our answer as a fraction, but if we want to write it as a decimal, that would be 4.5 centimetres, because 1/2 is the same as 5/10, and the first digit after the decimal point is the 10ths digit. Now, point C is twice as far from point A as it is from point B. On the scale above, mark one place where point C could be. So we know that the distance from A to B is 4.5 centimetres, and we need to write point C. It's twice as far from point A as it is from point B. So that will be another 4.5 centimetres, because if we have 4.5 and then another 4.5, it will be twice the distance from A as it is from B. So we need another 4.5 centimetres, so point C will be here. from point B, we could count on half a centimetre and then another 1, 2, 3, 4 centimetres, so that's 4.5 centimetres altogether. Look at the cuboid below. Draw 2 more faces to complete the net of the cuboid. So if this face here is our base, this face will fold up, this square face will fold up and so be one of the squares at the end, and then when this square has folded up, this rectangle will be able to fold all the way over the top. But we need a face here because we need to cover this edge, and if we have a square face at this end, we'll need a square face at the other end as well. Shade 1/5 of this shape. Now this question is confusing because we need to shade 1/5, but our shape hasn't been divided into 5 pieces, it's been divided into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. So what we need to do here, to find out how many pieces we need to shade, we need to find an equivalent fraction which has a denominator of 10, because we have 10 pieces in our shape. Now 5 times 2 is 10, 1 times 2 is 2, so because 1/5 is equivalent to 2/10, we need to shade 2 of these pieces, 2 of these tenths. So when we do that, we've shaded 1/5 of the shape. Shade more triangles on this shape so that 1/3 is shaded. Now 1/3 means that we have 1 out of every 3 triangles shaded. But in this shape, we don't have 3 triangles, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 triangles. So we need to find an equivalent fraction to 1/3, which has a denominator of 12. So 3 times 4 is 12, 1 times 4 is 4, so we need to make sure that we have 4 shaded triangles in total. So it doesn't matter which 2 triangles we shade, as long as we shade 2 more triangles so that we have 4 triangles shaded altogether, because 4 out of 12 shaded is the same or equivalent to 1 out of 3 or 1/3 shaded. Class 6 did a survey of mushrooms growing in a field. The diagram shows the distances of mushrooms from the centre of the field. How many mushrooms were more than 10 metres from the centre? So we have the centre marked here, and we know that the dots are mushrooms. So if we look at the line which shows 10 metres, we want to know how many were more than 10 metres from the centre. So we want the mushrooms on the outside of the circle. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 dots outside of 10 metres. So 14 mushrooms were more than 10 metres from the centre. Now, what fraction of the mushrooms were less than 10 metres from the centre? So here we need to work out how many dots we have inside the circle. So we can count 1, 2, 3, 4, 5, 6, 7. So we have 7 less than 10 metres, and we know from the first part of our question that there are 14 dots, so 14 mushrooms outside the 10 metre circle. Now 7 plus 14 is 21. So there were 7 less than 10 metres and 21 altogether. So as a fraction, we have 7 over 21, because remember, the numerator is how many we have, and the denominator is how many there are altogether. So our fraction is 7 over 21, which we could simplify to 1/3 if we divide both the numerator and denominator by 7. Seb had some cherries. Every day he ate 10 cherries and gave 5 away. After he gave the last 5 cherries away, he had eaten 40 cherries altogether. How many cherries did Seb have at the start? So we know that every day he ate 10 cherries and gave 5 away. We also know that altogether he'd eaten 40 cherries. Now 10 times 4 is 40, so we can work out how many he gave away by multiplying by the same number, and 5 times 4 is 20. So if he'd eaten 40 cherries by the end, then he'd also given away 20. And we want to know how many he had at the start. So if 40 were eaten and 20 were given away, that means there must have been 60 cherries altogether at the start. Here are 5 number cards. Use each card once to make every statement below correct. So we have the numbers 48 to 52, and we want to know which number is a multiple of 3, 4, 5, 6 or 7, and we can only use each card once. Now we know that multiples of 5 always end in a 0 or a 5, so that means 50 has to be the number card that is a multiple of 5. So start with the easier ones. So here I've started with 5 because I know the rule for multiples of 5. Now let's think which of these number cards is a multiple of 6, because we know our 6 times table and that goes beyond 52. Now the only number here that's a multiple of 6 is 48, so that must be our number card here. And we also know our 7 times table past 52, and 49 is the only number card that we have that's in the 7 times table. So now we need to find a multiple of 4 and a multiple of 3. 52 is our multiple of 4 because we know that all multiples of 4 must be even numbers, and the only cards we have left are 51, which is an odd number, and 52. So that means 51 is a multiple of 3. Now 48 is also a multiple of 3, but remember, we can only use each card once, so we need to write 48 as a multiple of 6. And we can check that 52 is a multiple of 4, because when we divide it by 4, we don't get a remainder. We can check that 51 is a multiple of 3, because when we divide it by 3, again, we don't get a remainder, so we know that it is a multiple. Write in the missing number. We have 8.5 plus 14.7 equals 10.2 plus something. So we know that with the equal sign, we need to have the same value on both sides. So what we can do is work out 8.5 plus 14.7, and when we use column addition, we get 23.2. So if this side of the equal sign totals 23.2, this side needs to total the same. So we have a missing number addition. 10.2 plus something equals 23.2. And when we have a missing number addition, we can subtract to find our missing number. So work out 23.2 minus 10.2. That gives us 13.0, which we can just write as 13, because all the 0 tells us is that we don't have any tenths, but just writing 13 tells us that as well. One jug contains water and the other jug contains oil. How much more oil is there than water? So if we look at the jug for water, we need to know what these little lines on our scale represent to find the level of the water. Now to get from 0 to get from the bottom of the jug to 200, we have 1, 2, 3, 4 lines. So we can find the value of each line by dividing 200, dividing the difference by 4, so by the number of jumps. And 200 divided by 4 is 50, because 20 divided by 4 is 5, And then if we have an end 0 in our dividend, we need an end 0 in our answer. So each of these lines represents an increase of 50. So we have 50, another 50 makes 100, and then another 50 gives us 150, and we can see that that's the level of the water. So we have 150 millilitres of water. And then if we look at the jug that contains oil, we can see that we have right in the middle of 400 and 600 millilitres, so that's 500 millilitres. Now the question asks how much more. So how much more is 500 than 150? Well, we can find the difference by subtracting, and 500 minus 150 is 350. So there is 350 millilitres more oil than water. Write the missing number in each calculation. So in both of these calculations, it's the divisor that's missing, and both calculations give a remainder. So we know that to check divisions with remainders, we can multiply the divisor by this number and then add this number to get the number that we started with. So if we do that in reverse, we can work out 25 minus 4, so that's 21, and then if we divide 21 by 3, we get 7. So that's our missing number, because 7 times 3 is 21, and then we need another 4 to get to 25. Now 35 divided by something equals 4, remainder 3. If we subtract 3 from our dividend, we get 32, and then we can divide 32 by 4 to get 8 as our missing number. And that makes sense because 8 times 4 is 32, and then from 32 we need 3 more to get to 35. Here is part of the morning bus timetable from Winton to Yansley. So we have Winton at the top and Yansley at the bottom, and it's important to understand what these columns are different buses that leave Winton at different times. So how many minutes does the bus take to get from Ingham to Dudley? Well, let's find Ingham and Dudley, and we could use any of the buses for this, but sometimes it's just easier or more simple to use the first bus. So we want to know how many minutes the bus takes, so we need to find the difference between these times. So we leave at 9:45. Now to get to 10 o'clock, that will be another 15 minutes, because there are 60 minutes in an hour, and 45 plus 15 is 60, so takes us to the next hour. Then, if we add on another 23 minutes, that takes us to 10:23, so takes us to the time it reaches Dudley. So altogether, the bus has travelled for 15 minutes and then another 23 minutes. So if we work out 15 plus 23, that tells us that it takes 38 minutes altogether to get from Ingham to Dudley. And notice also, if it's 10:05 and we add 38 minutes, that takes us to 10:43. And perhaps it would have been easier for us to use this bus here, because we don't need to cross an hour boundary. Now Megan is in Carston. She wants to be in Yansley before 11:30. What is the time of the latest bus she can take from Carston? So let's find Yansley, and she wants to be there before 11:30. So if she gets there at 11:35, that will be too late. So she needs the bus that gets to Yansley at 11:15. But it asks the time of the latest bus she can take from Carston. So our answer isn't 11:15. Instead, we need to move up and look at the time our bus leaves Carston. We can see that it leaves at 10:21. So notice we're finding the time she needs to get to Yansley by, and then looking up to see what time it leaves Carston. And it leaves at 10:21. So the time of the latest bus she can take from Carston is the 10:21. If she takes the 10:41, then she would be late getting to Yansley. Circle the number that is closest to 20. So we need to find the difference between the numbers that we're given and 20. First, we have 19.95. That's 0.05 less than 20, because if we work out 20 minus 19.95, we will get 0.05. And we could do that using column subtraction, so we could remember that 20 is the same as 20.00, and if we subtracted 19.95, we would get 0.05. Or if we added 19.95 and 0.05, we would get 20.00, so that's 20. Now 20.1 is 0.1 more than 20. 19.09 is 0.91 less, because 9 and 91 make 100, so 9 hundredths and 91 hundredths make one extra whole, so 19 becomes 20. 20.09 is 0.09 more than 20, and 20.201 is 0.201 more than 20. So we need to work out which of these numbers is smallest, because that will give us the number that's closest to 20. Remember, it's easier to compare decimals if we write zeros on the end, so that all of the numbers we're looking at have the same number of decimal places. So because this number here has 3 decimal places, I've put zeros on the end of these numbers so that they all have 3 decimal places. And then it's easier to spot that 0.050 will be the smallest difference, which means that 19.95 is closest to 20, because the difference is only 0.05 and all of our other numbers have a greater difference. Now it might look like 0.1 is the smallest difference, but remember, this 1 is in our tenths. If we have 5 in our hundredths, that's less than having 1 in our tenths. So 0.05 is less than 0.1. Calculate 936 divided by 36. So first we need to work out our 36 times table. 36 is 1 times 36. If we add another 36, we get 72 for 2 times. Another 36 gives us 108 for 3 times. We have 144 for 4 times 36, and 180 is 5 times. And when we get to 5 times, we can look back at our question. So if we take the first 2 digits together, we have 93. So we need a number in the 36 times table which is as close to 93 as possible, but not more than 93. So here that's 72. And because 72 is 2 times, we can write 2 in our answer line. Now we subtract and bring down. 3 minus 2 is 1, 9 minus 7 is 2, and if we bring down the 6, we have 216. Now we haven't got as far as 216 in our 36 times table, but if we add 36 to 180, that gives us 216 for 6 times 36. So 6 is the final digit of our answer. Chen has some right-angled triangular tiles. He makes this shape with 4 of his triangular tiles and 3 square tiles. What is the perimeter of Chen's shape? So the perimeter is the total distance around the outside of the shape. Now we know that the longest length of the triangle is 13, so we can write 13 where we see the longest length of a triangle. But we also have these sides here. Now we know that this length is 5, and if we move that across, that tells us that this length of the square must be 5 as well. And with a square, all sides are the same length, so we can write 5s next to the lengths of the squares. So remember, the perimeter is the total distance, and we have 4 distances of 5 centimetres, so that's 20 altogether, and we have 4 distances of 13 centimetres, and 4 times 13 is 52. Now the perimeter will be the total distance, so if we add those numbers, we get 72 centimetres as our perimeter. The numbers in this sequence increase by equal amounts each time. Write in the 3 missing numbers. So we have 1 and 7, and to work out what the sequence increases by each time, we need to work out how many jumps. So that's 1, 2, 3, 4 jumps to get from 1 to 7, and the difference between 1 and 7 is 6. So with 4 jumps, we get 6 more. That means with 1 jump, we can divide 6 by 4, and that gives us 1.5. So with each jump, we increase by 1.5. Because if we have 1.5 4 times, that's an increase of 6, and the difference between 1 and 7 is 6. So 1 plus 1.5 is 2.5, plus 1.5 is 4, plus 1.5 is 5.5, and then we can check plus 1.5 is 7. In this diagram, R is an equal distance from P and Q. What are the coordinates of R? So we have point R here, and when we write coordinates, we always write the x coordinate first. So the x coordinate will be 50, because if it's an equal distance from P and Q, and point Q has an x coordinate of 100, the coordinate for point R will be half of 100, so will be 50. And then we write the y coordinate. We can see that P has a y coordinate of 30, so the y coordinate for R will be 15. It's an equal distance, so it will be half the size of 30, and half of 30 is 15. So R has the coordinates 50, 15. Megan and Chen each have a bag of counters. Megan's bag has 5 blue counters and 5 green counters. Chen's bag has 10 blue counters, 5 green counters, and 5 red counters. They each take a counter from their bag without looking. Chen says, "I am more likely than Megan to take a blue counter. Is Chen correct? Explain how you know." So Chen is wrong. Megan has 5 out of 10 counters that are blue, because she has 5 blue counters and 5 plus 5, so 10 counters altogether. As a fraction, we can write that as 5/10. Chen has 10 out of 20 counters which are blue. Chen has 10 blue counters, but 20 altogether, because 10 plus 5 is 20. So as a fraction, we can write that as 10 over 20. Now 5/10 is equivalent to 10/20, because we can multiply both the numerator and denominator by 2. So they are equally likely to take a blue counter. A 5 in 10 chance is the same as a 10 in 20 chance, because those fractions are equivalent.